Hi, my name is Richard Armenta, and today we're going to be talking about measures of screening tests. Before we get into calculating measures of screening tests, let's first talk about the goal of screening tests. So the purpose of a screening test is to identify or detect disorders or disease in a population of people who don't have symptoms already. So one of our goals is to be able to identify those diseases or disorders early enough so that we can implement either lifestyle changes to prevent the onset of those diseases or to get those people into early treatment so that it can be most effective. Screening tests are not considered to be diagnostic, but are rather used to select a sample of the population who might need further testing to identify the presence or absence of disease. So in order to evaluate the quality of our screening tests, we use a couple of different measures, some of which I have here on the board. So the sensitivity of a screening test is used to detect the ability of a test to identify those with the disease, while the specificity of a screening test is a test's ability to identify or correctly identify those without the disease. So in order to calculate those, we use a 2x2 table as shown here, like we use with many other measures of association in epidemiology. So if we start out with our 2x2 table, one thing that we must know in order to evaluate the ability of a screening test to accurately detect those with and without disease is who actually has disease in the population starting out. So if we look at our 2x2 table, we start out with those that have the disease on the top, and we have people who are positive, and we have people who are negative for the disease. And then we use our screening test to see how accurately it's going to detect those with and without disease. So we'll have those who are positive on our screening test and those who are negative on our screening test. As I mentioned, we already know when we're evaluating our screening test who does and does not have disease. So if we start out with a hypothetical population of 1,000 people, and we know that 60 of those 1,000 have the disease of interest, that would give us an overall prevalence of 6% in that population that we're working with. And then among those that we test on this screening test, we come up with 70 people who test positive on our screening test. And so if we start to fill in our 2x2 table so that we can calculate our sensitivity and specificity, we know that on our screening test, of those who have the disease, we have 45 people who test positive. What that would end up being is our true positive rate. So we would have label this as TP, or true positive, for the people who test positive on our screening test who actually have the disease. And then if we move over to our second cell, or our cell B as we often call it, we would have 25 people who test positive on the disease, or on the screening test, who don't have the disease. And what that would be is our false positive. So we're going to label that FP. And then moving down to cell C, we would be looking at people who have the disease, but who test negative. And if we just fill in our numbers here, that would be 15 people. And we're going to label that false negative. And then lastly, moving over to our cell D, we're going to have our true negative people. And what that is everybody who does not have the disease in our population who also tests negative on our screening tests. And that's going to give us a total of 915 if we fill in the number. And so now what we can do is we can use our 2x2 table to calculate our sensitivity and specificity. So as you can see here, our sensitivity is calculated by looking at our number of true positives over our true positives plus our false negatives. And so if we look at our 2x2 table to see why we're calculating it that way, as I mentioned earlier, the sensitivity is the proportion of those with the disease who test positive. So if we look at this top cell, that's our true positive, so that's the proportion of those with the disease who test positive over all of those with the disease, which would be our true positive, or over our plus our false negative. And so if we calculate our sensitivity here, we're going to end up with 45 over our true positive plus our false negative, which we know is 60. And that's going to give us a total sensitivity of 0.75. And we can interpret that by saying, of those who have the disease, 75% are going to be correctly identified by our screening test that we're evaluating here. And so now if we move on to our specificity is, again, the ability of the test to identify those without the disease. And so if we look at our 2 by 2 table again, what we really want to increase on our specificity is the number of people who are our true negative, so who are in this cell here. So our formula for sensitivity is our true negative over the true negative plus the false positive. So if we fill in the numbers from our table, that would give us 915 over 915 plus 25, which we'll fill in here too, is equal to 940, which would be 940. And that gives us a total specificity, if you plug that into your calculator, as 0.973 or 97.3%. So what that means is that of those who do not have the disease, 97.3% would be correctly identified as not having the disease on our screening test. One thing that I want to mention before we move on is that our sensitivity and specificity are related to each other in that typically as our sensitivity increases, our specificity is going to decrease. And let's talk about why. So our sensitivity of our test, as we know, is the true positives over the true positives plus the false negatives. So if we increase the sensitivity of our test, what that's going to do is increase the number of people that we test positive on the disease. So we're going to increase this cell here. But by increasing the number of people who test positive on the screening test, what we're actually also going to do is increase the number of false positives. So we're going to be getting more people who test positive on our screening test who don't have the disease. So this number is going to go up. What that's going to do, if we look at our formula for specificity as we increase our sensitivity, is that our false positive is calculated here in the denominator of our formula of specificity. So what that's going to do is actually decrease the specificity of our test by increasing the sensitivity. The same is true if we increase the specificity of our test. So as you remember, the specificity of our test is the true negative over the true negative plus the false positive. So if we increase the specificity so that we are testing more people, so increasing our cell of true negative, so we're getting more people who don't have the disease who are testing negative, we're also going to test more people who have the disease who test negative. So what we're going to end up doing again is we're going to increase the denominator of our formula for our sensitivity and then in turn decrease the sensitivity of our test. So what does this all mean? What does that mean if you test positive on a screening test? Well, that's what we're going to talk about next, going into positive predictive value and negative predictive value.